Hi guys, welcome to another video. Today we're going to look at transverse waves. So let's go through the scenario together. So it says a snapshot of a transverse wave is given below. The wave has a frequency of 0.8 Hertz and is moving from left to right. The first question says define the term frequency. So the frequency by definition is the number of complete waves. Complete waves is a keyword that passes a fixed point in 1 second. So suppose on the equilibrium you have your fixed point here, call it x. So the number of complete waves, this would be a complete wave from there to there. The number of complete waves that passes this fixed point in 1 second is frequency, is defined as frequency. So the next question says name the following 2 points that are out of phase. So A and B are out of phase because A lies on the equilibrium and leads to a rise in disturbance, and B is a point on the trough. So A and B are points that are out of phase. Another set would be C and D because C leads to a rise in disturbance and C is on the equilibrium and D is a crest. So another set of points would be C and D. A and C, however, are both points on the equilibrium and they both lead to a rise in disturbance. So A and C are points that are in phase, so we can't include it as part of the solutions. The next question says determine the wavelength of this wave. So to find the wavelength, you need to bear two things in mind. This is what you have to bear in mind. The wavelength is the distance between 2 points that are consecutive. That means these 2 points follow each other, and these points also have to be in phase. If you look at the schematic, you can actually form a point here, call it E, and you'll see that A and E are consecutive points that are in phase because you can see that A is on the equilibrium and it leads to a rise in the disturbance, and E is also on the equilibrium and leads to a rise in the disturbance. So this here forms a complete so this here forms a complete wave cycle, and the distance between these 2 points is a wavelength. And if you analyze further, you can see here's another full cycle. So this here is another full wavelength, lambda. And you can see there's boundaries here also. The 6 meters lies between 2 wavelengths. So you can say 2 lambda is equals to 6 meters. Therefore, lambda should be equals to 3 meters. And the next question says we need to determine the amplitude of the wave in meters. So the amplitude by definition is the maximum displacement a particle can assume from the equilibrium. So if you consider the equilibrium here, the maximum distance the particle can assume would be this distance here. So this becomes your amplitude. So we're not directly given the amplitude, but if you can consider another point on the equilibrium, so the maximum distance from that equilibrium again to the trough would constitute another amplitude. So in essence, this 18 centimeters is 2 amplitudes. So you can say 2a is equals to 18 centimeters. But recall they want the answer in meters. So you can divide throughout by 2 here. So 2 and 2 cancels. 2 goes into 18 9 times. Therefore, A is equals to 9 centimeters or 0.09 meters, because 1 meter equals 100 centimeters. So you should divide by 100. Thank you guys so much for watching. See you in the next one.